Alright, 2004 HSC physics paper. Let's go through the multiple choice. A picture shows a game of cricket. The picture shows two consecutive shots by a batsman. Both balls reach the same maximum height, meaning that both balls must have the same y velocity. But ball Q travels twice as far as ball P. Which of the following is different for balls P and Q? So time of flight? Well, that's not right, because both balls have the same y velocity. They reach the same height. Initial velocity? Yeah, that's true, because Q travels twice as far in the x direction as P. So B is right, and C, gravitational force, gravitational acceleration, those should be constant. The diagram shows two planets, X and Y, of mass m and 4m respectively. At a distance d from the center, a planet y of the acceleration due to gravity is 4 meters per second. What is the acceleration due to gravity at distance d, so same distance, from the center of planet X, and its mass is only 1/4 of planet Y, therefore its acceleration is also going to be 1/4, and so the answer is A. A spaceship at a distance r meters from the center of a star experiences a gravitational force of x newtons. The spaceship moves a distance of r/2 towards the star. What is the gravitational force acting on the spaceship when it is at this new location? So remember that force is g m1 m2 over r squared. So this factor of 2 is going to actually get squared and become 4. And since it's 1 over half, it's just the same as multiplying the top. So it's going to be a half squared, which is going to be 4. You see, 4x newtons here. Alright, an object of rest mass 8 kilos moves at a speed of 0.6% speed of light relative to an observer. What is the observed mass of this object? Alright, let's get our calculator. 0.6 squared 1 minus 0.36 equals 0.64 square root 0.8 and 0.8 times 8 kilos. Sorry, it's 8 divided by 0.8. That's the formula. We get 10. Alright, B. So remember, moving objects gain mass. So F equals ma, and we want m to increase so that it doesn't go faster than the speed of light. Alright, question 5. Two spaceships are traveling at relativistic speeds. And then one spaceship shines a light beam forward. Now remember, the speed of light is always equal to c, so the answer is A. Alright, a ball is dropped by a person sitting on a vehicle that is accelerating uniformly to the right, as shown by the arrow. Which of the following represents the path of the ball shown at equal time intervals observed from the frame of reference of the vehicle? So, accelerating uniformly. So it can't be A, because then we're in the same inertial frame of reference. This would be if we had uniform velocity. So it's not A. So it can either be B, C, or D. This implies that the ball goes faster than the actual trolley. So this can't be right. Yeah, this can't be right. So it can't be C. Alright, so now we're up to B and D. B shows me that it looks like to me it's not accelerating in the x direction, in which it should. And while B shows me a straight line, which is getting further and further apart, is what we would expect. And now ignoring air resistance. So the answer would be B, most probably be B. That's what I think. Alright, question 7. Why do some main electrical appliances in a home need a transformer instead of operating directly from the mains? Well, some require a lower voltage. Yes, that's true. They require DC rather than AC. That's also true, but transformers don't do that. That's also true, but again, transformers don't do that. They consume less energy than a similar device without a transformer. I'm not so sure what this means, so I would circle A. Question 8. A transformer which has 60 turns in the primary coil is used to convert 3 volts into 12 volts. So it needs 4 times more turns, so we need 240 turns. And it's a step up. It's a step up transformer. Okay, question 9. An electric DC motor consists of 500 turns of wire formed into a rectangular coil of dimensions that. So we need to calculate the area. The coil is a magnetic field of 1 times 10 to the minus 3 teslas. A current of 4 flows through the coil. What is the magnitude of the maximum torque and the orientation of the plane to the coil relative to the magnetic field when this occurs? So the maximum torque appears when it's parallel to the field, always. And now we need to do some math. So this is going to be 0.02. Alright, let's do this. Cancel. Alright, so first term, 500 times 0.2 times 0.1, okay, times 4, and then times divide by 1000. 0.04 Newton meters, so A. Okay. A disk magnet has poles facing opposite surface and insulated copper. The instant the wire is connected to a DC battery supply, the wire was observed to move in the direction of the arrow. Okay. Which statement describes the direction of the magnetic field and the direction of the current in the wire consistent with this observation? So our palm points in that direction. So current has to go from X to Y. That's what happens when we apply the right hand rule, and then our fingers point vertically upward. So the answer would be A. Alright, question 11. An electromagnetic is attached to the bottom of a light train which is traveling from left to right as shown. When a large current is passed through the coils of electromagnetic, the train slows down as a direct result of the law of conservation of energy. In which way of the following devices is the law of conservation of energy applied in the same way? So we have A DC motor, not in the same way. B, a loudspeaker, again, not in the same way. C, an induction motor. Induction motor is used to speed things. Anyway, what's D? An induction cooktop. Induction cooktop uses changing magnetic fields. Well, induction motor doesn't really change it. That sort of changes the orientation. It's more of a squirrel cage. Anyway, so the answer here is C, induction motor. I'll maybe get back to that one. Photographs of 2 gas discharge tubes are shown. What causes the variation of patterns or striations in the gas discharge tubes? Different gas. Nope. This is just a memory. it's different gas pressures in the tube. And what's happening here is that as the electrons go through the air, they accelerate, and when they accelerate, they interact with molecules, and some reaction happens that causes it to spark light. 13. Compared to silicon atoms, phosphorus has one more electron in the outer cell, and boron has one less electron. Which of the following is the correct statement? An N-type semiconductor is produced when silicon is doped with phosphorus. Yes, that's true. And a P-type semiconductor when silicon is doped with boron. Yes, that's also true. So N stands for negative, but it isn't really. It's neutral charge. It just has one more electron, while P means positive, but that's also not true. It just has one less electron. So you can consider it as a whole, which is a positive particle. Well, not really. Anyway, 14. The minimum amount of energy needed to eject an electron from a clean aluminium surface is that. What is the maximum wavelength of incident light that can be shown on this aluminium surface in order to eject electrons? So we use our equation E equals HF, then we go to E equals H lambda over C, no, C over lambda, and then we just solve for lambda. So I'm not so sure what that'd be. Anyway, the graph shows the intensity wavelength relationship of electromagnetic radiation emitted from a black body cavity. In 1900, or in the 19th century, Planck proposed a mathematical formula that predicted the intensity wavelength relationship consistent with the experimental data. Okay, this is just a memory question. The success of the formula depended on which of the following hypotheses? The intensity of light is dependent on the wavelength. Intensity, nope, that's not true. Light is quantized with the energy of light quantity depending on the frequency. This is true. Light is a wave whose intensity, not so sure about that. Light is quantized with the energy depending on the size of the cavity. No, I don't think that's true. So I think B is right. And that is it. Thank you.